All right, so in this video, I'm going to go over a fairly big topic in statistics. It's ANOVA, or analysis of variance, and we really use this to compare multiple groups. So in the previous video, I talked about comparing two different groups. Now, with this type of statistical task, we can compare multiple groups at the same time. Um, so we have the same assumption as the two-sample test, that the observations are independent in some way of each other. So essentially they're coming from different people. Our null hypothesis, when we construct these, are somewhat similar to the independent test, but a little bit different. Our null hypothesis is basically saying that all the groups are equivalent or equal to each other. Our alternative hypothesis is saying that at least one of these groups is different than the others. We don't know which one, and that's kind of a key important part, but at least one of these groups is different from the other. Again, like the previous video, a lot of the work is going to be done by the regression function in the stats add-on package, and we're going to use that p-value from the ANOVA output to compare to our alpha level, like we did with the two-sample t-test. And generally, we're going to want an alpha less than a p-value of 0.05 to reject the null hypothesis and accept the alternative hypothesis. The other thing we're going to want to consider is that we want to calculate a new alpha level when we're performing multiple comparisons, not corrections, comparisons, by using the Bonferroni correction. So multiple comparisons are basically, and this will become more clear, if we're doing an ANOVA, we're comparing three different groups here in this case of this hypothesis, and let's say we get a significant value, a significant p-value, so we reject the null, that one of these groups is different. We're going to kind of zoom in and want to look at just one comparison. And then we're going to want to do a paired samples t-test to look at this one comparison, just like I showed you in the, not a paired samples t-test, excuse me, an independent samples t-test, like I showed you in the previous video. But we're going to want to use a slightly different alpha for that comparison. Instead of using this 0.05, we're going to divide that alpha by the number of comparisons that we actually want to make. And so with three groups, the maximum amount of comparisons we could make would be 3, and let's say we wanted to compare group 1 to group 2, group 1 to group 3, and group 2 to group 3. That's all 3 comparisons. Then our alpha of 0.05 would be divided by 3, and we get about a value of approximately 0.017. And so we want to use that new alpha for these independent samples t-test comparisons that we're going to do. That's kind of a mouthful. Read through this section. It's not going to be a hugely emphasized within this chapter, because this is the reason why we're doing this, to control what's called type 1 error, and that's discussed in one of the previous sections. But this is an important aspect, and I'll go into it a little bit. So in general, ANOVA is an entire course within statistics. We could go over this for a whole entire semester. So we're not going to go all into the nitty-gritty details, but just how to construct a basic hypothesis test. So let's go into the data. So within ANOVA, we're comparing groups that are generally more than 2 groups. So the only variable we have in this data set that has more than 2 groups is this undergrad major. So what we're going to do, very simple, if we wanted to look at, do the 4 groups, do they have equivalent means? And let's look at GPA, or are they different? That's basically the question, the research question that we're answering. So we're going to go up to add-ons, statistics, go to regression. We're going to go to a response variable is GPA, because that's what we want to look at. A predictor variable is undergrad major. Where is that at? There it is. We don't need any of these other plots for right now. And we don't need a filter at all, because we're comparing all 4 groups to each other. We're going to go ahead and click Create. And now we get this coefficient, and we were previously looking at this for the t-test, but I'm going to ask you to ignore this. So we're not going to focus on that. We're going to focus on this ANOVA table, and I'll highlight this in green just to kind of make this stand out a little bit. So we're going to look at this ANOVA table, and yes, there's a lot going on here. These residuals, totals, sums of squares, mean squares, F value. Essentially, this is what an entire course on ANOVA would go over. We're just going to highlight and zoom in and just focus on the p-value. So remember, we're using an alpha set at 0.05 to determine whether these four groups are, yes, four groups in this case are significantly different than each other. So our alpha, just to recall, is equal to 0.05. Oh, let me just 0.05. That's what our alpha, not 0.06, 0.05. There we go. And because 0.0244 is below an alpha of 0.05, we're going to reject the null hypothesis. We're going to reject the null and accept the alternative. All right. Now, what is the alternative? Well, the alternative is that one of these groups, whether it's one comparison, whether it's psychology to no major degree or psychology to other science degree, one of those comparisons is probably different. One of those means is different than the other means in that group. So now what we need to do is say, well, where is this difference occurring? And we're going to follow this up with multiple comparisons, and we're going to use kind of two sample t-tests. So let's go ahead and do that. So let's go ahead and look at, we created some filter variables in our last test. So we're going to say filter psych versus or other psych. We're going to click on this. And this is just going to zoom in. But let's back up just a second. Let's say we want to make two comparisons here. So we want to compare psych to other science degree, and we also want to compare psychology to no major declared. So we're going to be doing two comparisons, and I'm just going to use this space here. So we're going to be forming two comparisons. Our previous alpha was 0.05. That was our previous alpha to start with. That's what we used for this significant sort of F test or ANOVA test. So our new alpha for multiple comparisons, let's just give us a little more space here, and we'll move this over. Okay, our new alpha for multiple comparisons is basically, let's do this. Number of comparisons we're performing is 2. So because the two comparisons we're going to be looking at is psych versus other science, I think psych versus no major declared. Those are the two other comparisons. So that's two comparisons. We're going to take this 0.05, so we're going to write equals 0.05 divide by 2, and our new alpha is going to be 0.025. That's our new alpha that we want to use for all our multiple to determine significance and determine whether we reject or retain our null hypothesis. So let's go ahead and perform those comparisons. So we're going to go to this regression analysis. We're just going to add the filter for the first comparison. So that's psych to other science degree. We're going to hit OK. We don't need to change anything else. We're going to hit create. Now we're going to focus on this coefficients table. Although we could look at the ANOVA table because it gives us equivalent p-values. That's just a little bit of an extra fact. It doesn't give us these estimates of the difference. It doesn't give us a standard error t-value. It gives us an f value. But these two different tests arrive at the same conclusion, and they will always arrive at the same conclusion. That's just an extra little tidbit. So here what we can see is the undergrad major is is about half a unit or 0.537 higher in psychology than other science degree. So it's higher. Psychology is higher than other science degree, and it's significant. It's significant at, well, there are p-values 0.0117. Remember our previous alpha that we used, and we're just 0.05, but our new alpha, because this is coming after the ANOVA, is 0.025. And now what we're saying is this p-value less than 0.0117 less than this? And you say, yes, it is. It is less than that, so we're going to reject the null and say that psychology is significantly higher, psychology student majors have significantly higher GPAs than other science degrees. So if we wanted again to look at the other comparison was psychology to no major declared. We're just hit OK. We'll hit create, and we're going to zoom in, focus on this coefficients output. We jump to the p-value. Ignore this intercept p-value. Just ignore that. We always want to focus on this line right here. 0.2229 is clearly above our new alpha of 0.025. So we're going to retain the null hypothesis that these two groups, psychology and non-major declared students, are equivalent. Alright, so in this video I've gone over the ANOVA, a basic way to compare multiple groups, basically more than two groups. I've shown you how to do this and construct hypotheses related to the ANOVA. I've also shown you how to perform multiple comparisons and to adjust your alpha level when comparing these, when performing these follow-up comparisons or these multiple comparisons after you performed the ANOVA. Ask any questions you have about this subject. Obviously, there's a lot more to this subject, and the book goes into some of those details in the book, in the videos. We're not going to go into all those details because some of this stuff would take a lot longer to explain than we have time for in this course. But if you get the basic gist of these things, I think you'll be doing just fine for the quizzes.